In this video, I am going to do 2003 AB2. It talks about a particle moving along the x-axis, and it gives you the velocity function. It also gives you the initial position when time is 0. The particle is at x equals 1. Letter A wants to know when the acceleration of the particle, what the acceleration of the particle is when time is 2. And that is very similar to the question that we just did. The second part of the question says, is the speed of the particle increasing at t equals 2? So I would like you to pause the video and see if you can do it on your own, and then play the video to see if you got it right. Okay, let's see if you got it right. So I'm going to take the derivative of the velocity, and I want to evaluate it at 2, and that will give me the acceleration at 2. I'm going to use my function on my calculator in deriv, and I am going to type in my function using x's and tell it to evaluate it at 2. And when I type all of that in, I get 1.58. So I've done the first part of the question, but now I need to figure out if the speed of the particle is increasing or decreasing. And the way I do that is I look at the velocity and the acceleration, the signs, and see if they're the same. So I'm just going to take 2 and plug it into my velocity equation. And when I do that in my calculator, I get negative 2.728. Now looking at these, I can see that the signs are different. So that tells me that the particle is slowing down. So I'm going to write the speed of the particle is decreasing because acceleration at 2 is positive and velocity at 2 is negative. Letter B says find all times t in the open interval when the particle changes direction. So I know when it's changing direction that means the velocity is 0 because it's changing from left to right. So I am going to take the velocity function and evaluate it when t equals, when the velocity function equals 0. Okay, so I've got it all separated out already, so I'm going to set each part equal to 0 and solve it. So over on the right, I'm going to get t equals negative 1. Well, we know we can't have a negative time, so I'm not going to use that one. Over on the right, I need to evaluate sine of t squared over 2. When would that be equal to 0? Well, I know that sine is 0 when the angle is either 0 or pi. So I know that 0 or pi has to be equal to t squared over 2. So t squared over 2 equals 0 when t is 0. And t squared over 2 equals pi when t is the square root of 2 pi. So t equals 0, the particle is not going to be changing direction because that's when it starts. So my only real answer here is t equals square root of 2 pi. Okay, so just to make sure, I'm going to put this on a sine line. Okay, and we can actually graph this in our calculator to see where it's positive or negative. And when I graph it, I see that it's negative here and positive here. So in fact, it is changing direction. If these had been the same sign, then it wouldn't have been changing direction. So the last thing we need to do is to write a justification. So I'm going to write, since the velocity is less than 0 when t is in between 0 and square root of 2 pi, and velocity is positive when t is greater than square root of 2 pi. Oh, and we actually had boundaries here, so I needed to, our boundary was 3. So between square root of 2 pi and 3, the particle changes direction when t equals square root of 2 pi. Okay, the next question says find the total distance traveled by the particle from time t equals 0 until time t equals 3. Well, I know total distance is the integral of the absolute value of velocity from 0 to 3. So I'm just going to type that into my calculator using the Math 9 button. And typing it all in. Of course, I use X's. Make sure you're careful with your parentheses here. And I'm going to evaluate that from 0 to 3. And when I type that in my calculator, I get 4.334. So that is my total distance. Okay, the last question says, during the time interval 0 to 3, what is the greatest distance between the particle and the origin? So I'm actually going to go back and look at my sine line, and I see that square root of 2 pi is a minimum, and so that's what I'm going to evaluate, because the minimum would show me that's the largest distance between the particle and the origin. So I am going to evaluate my position when t equals 2 pi. So I want to know what is x of the square root of 2 pi. Okay, so in the beginning of the question it told me that when time was 0, the particle is at x equals 1. Okay, so to evaluate my position at this point, I need to take into account where it was when it started, and then add the distance, the displacement that it's moved. So I do that by adding the integral of my velocity from 0 to square root of 2 pi. And I don't want to do absolute value. I just want to integrate the function because I don't care. I want my positives and negatives to cancel out because I want that true distance away from the origin. So I'm going to do that in my calculator. Okay, so I know the position at 0 was 1, and when I integrate in my calculator, I get negative 3.265. And when I add that together, I get negative 2.265. So the furthest distance away from the origin is negative 2.265. Okay, so we still need to justify our answer, and I like to kind of think of it as in a visual way. So I'm going to think about when time is 0, x equals 1. So if I've just got my number line here, and this is my position, here's 0, here's 1. This is where I'm starting from, okay? And I'm going to move all the way over to when time is square root of 2 pi. I'm going to move all the way over to negative 2.265. Then, at the end, I know the total distance traveled has been 4.334 that we figured out already. So to get back to the origin, I've got to travel 2.265 more to the right. Okay, but if I add that together twice, 2.265 plus 2.265, that's still going to be less than my total distance traveled, which was 4.334. So I know that wherever I end up is still to the left of the origin. So my furthest distance away from the origin is here at negative 2.265. So how do we write that in a sentence? So we are going to write, since the total distance traveled is 4.334, the particle is still to the left of the origin when t equals 3. So that tells me this minimum value over here has to be the farthest away from the origin. Okay, so therefore 2.265 is the greatest distance from the origin.